This is an AS statistics question on probability distributions. A bias spinner can only land on one of the numbers 1, 2, 3 or 4. The random variable x represents the number that the spinner lands on after a single spin, and the probability that x is equal to r is equal to the probability that x is equal to r plus 2, for r is equal to 1 and 2. Given that the probability of x equals 2 is equal to 0.35, part A, find the complete probability distribution of x. So the first thing to note is that a probability distribution is when we take the probabilities and outcomes and put them in a table. Our table is going to have the outcomes on the top row, the outcomes of x, 1, 2, 3 and 4. And the bottom row of our table is going to have the probabilities of each of those outcomes of x. Now, we've been told in the question that the probability that x is equal to 2 is 0.35, so that can go in straight away. And then we've also been given this extra information here. Now what we do is we substitute r equals 1 into it and then r equals 2. So when r is equal to 1, what we have is the probability that x is equal to 1 is equal to the probability that x is equal to 1 plus 2, that's this bit here, over here, which is 3. So the probability of 1 and 3 are equal. When we do r is equal to 2, we'll get the probability that x equals 2 is equal to the probability of x is equal to 2 plus 2, which is 4. So the probabilities of 1 and 3 are the same, the probabilities of 2 and 4 are the same. We have the probability of 2, so the probability of 4 is the same. To find the remaining probabilities, we're going to add these two up and take them away from 1. So 1 minus 2 times 0.35 gives us 0.3. That needs to be shared out between the outcomes 1 and 3. We know they're the same. So 0.3 divided by 2 gives us 0.15. So that gives the probabilities for 1 and 3 as 0.15. Ambrose spins the spinner 60 times. Part B, find a probability that more than half of the spins land on the number 4. Give your answer to 3 significant figures. Now for this part of the question, part B, it is a binomial distribution. We have a number of trials, we have a probability that we need to work out more than half, and we have a probability, the probability that the spinner lands on a number 4. Now I'm going to set my random variable up y, and this is going to be the number of, now whenever you set up a random variable, it's always the number of something, so the number of times the spinner lands on a 4. Now this is a binomial distribution, so y is a binomial distribution with 60 trials, and the probability that it's going to land on a 4 I get from my table here, which is 0.35. I need to work out the probability that more than half of those spins land on a 4. Now more than half, well, half of 60 is 30, so more than half means more than 30. That is equal to 1 minus the probability that x is less than or equal to 30. Now we can do this on our calculator or use tables. So this will give us 1 minus 0.994101 and so on. On my calculator, it gives an answer in standard form. I just like using decimals. So if you use the shift or second function and then a button that says ENG engineering, that will change it to a normal number, decimal form. So I've got 0.00588898 and so on. Now you can give your answer in standard form, but the question does say, the important bit is that we give our answer to 3 significant figures, whether in decimal form or standard form, and that will give me 0.00589 to the correct 3 significant figures. The random variable y is equal to 12 over x. Part C, find the probability that y minus x is less than or equal to 4. Now there's a couple of ways I can do this question. I could set up a new table for y and work out the probabilities that way. But the way I'm going to do it is I'm going to take this y is equal to 12 over 4 and substitute it into here. That means that the probability that y minus x is less than or equal to 4 will be the same as the probability as 12 over x minus x is less than or equal to 4. I'm going to multiply everything inside the bracket by x, so I'll get the probability of 12 minus x squared is less than or equal to 4x. I'll bring everything to one side, so now I've got a quadratic, so it's the probability that negative x squared minus 4x plus 12 is less than or equal to 0. What I'm going to do is times everything here by -1, which means reversing the sign to greater than or equal to. So now I'll have the probability of x squared plus 4x minus 12 is greater than or equal to 0. I can factorize what's in here. So the probability of, now let's see, I want two numbers that multiply to give me -12 and add to give me 4, so that's going to be 6 and 2, and I want a +6 and a -2. Now if I draw like a little quadratic graph so that I can see what I'm looking at, so here's my U-shaped quadratic. The roots from this are going to be -6 and 2, so just mark those in. So I've got a -6 here and I've got a 2, and I want to know when this is greater than or equal to 0, so that's going to be this part of the graph and this part of the graph here. So this now works out to be this question: the probability of, and I want these bits, x less than or equal to -6, and the probability that x is greater or equal to 2. Now I go back to the table and I find these probabilities. Now when is it less than or equal to 6? Never. So that's going to be 0. And when is it greater than or equal to 2? For these three values here. So I'm only really interested in the probability that x is greater than or equal to 2, and that's going to be the 0.35 plus the 0.15, that's a probability of 3, and a probability of 4, 0.35. If I add all of those together, I get 0.85. So answering the original question, the probability that y minus x is less than or equal to 4 is equal to 0.85.